Hello, and welcome to another session of our BuildOn UAE series. So my name is Alam Muhtasib, and I'm a solution architect based out of Dubai. Today, we will be taking a look on the different ways that you can move your data from on-premise to AWS Cloud, and vice versa if the need arises. We will discuss the different services and options that you have, and what criteria to use in order to determine which service is best fit for your data migration story. Then we will dig deeper into the specifics of each of these data transfer services and how basically they work and which use cases are they suitable for. Now, hopefully by the end of this session, you will have a clearer picture of how to go about migrating your data to the AWS cloud and distinguish between the need of doing offline or online migration and basically which works best for each scenario. Now, with that being said, there are mainly two questions that you need to answer in order for you to plan your data migration journey and choose the best services and approach that is possible for you. Basically, the first question is, why do you want to migrate your data to the AWS cloud to begin with? And the second is, what kind of data you're planning to migrate? Are you, for example, migrating your data perhaps to free up some storage capacity on your own premise? Or is it that you're embarking on a big data analytics project, for example, that involves having the data lakes on the cloud and gathering data from different B2B partners in addition to your own homebrew data, for example? Maybe you're looking for a more efficient, reliable, and cost-effective way to replace your historical backup and archives, such as your LTO tapes library. Or maybe you want just to add some extra resilience to your databases by having an active replica running in the cloud as part of your modernized disaster recovery strategy. Or is it as simple as you have some content that you would like to share and collaborate with others or business partners that are globally available while avoiding taxing your network? Now, what kind of data will be transferred is another question, as we said, and it helps you determine which service is best fit for your need as well. For example, are you talking about archival backup files, or are they structured databases? Or maybe you're looking basically to migrate your SAN or NAS storage, or having an SFTP file sharing mechanism on the cloud. Now, answering these questions becomes very crucial for your data migration technology selection and basically how you set up your migration workflow as well. For example, having an analytics project that needs your data to be moved into the cloud and put it in a data lake, and still you needed to have it for cross collaboration and ingestion of data from public sources, for example, and while you need to still process that data locally for some specialized tools you have on premise. So this means that you will need to have a copy or a cached copy or a portion of that data on premise at all time, while you're keeping the bulk of the unused data in the cloud. Now, this means, for example, a storage gateway service would be a good fit for you. This is just an example of how deeper understanding of your use case can basically contribute to your decisions and influence your technology selection. So next, we will look into the different services that AWS offer and explore the different use cases that they cater for. Now, some use cases might end up combining two or more services, but more on that in just a minute. So as you can see, AWS offers breadth of services that are designed to cater for different scenarios in your data transfer journey, starting from simply having cloud-based managed SFTP file transfer service that enables you to send, receive files using FTP, SFTP, FTPS protocols, and store these files in AWS highly reliable, in fact 11 nines of reliability, S3 object storage. However, if you need to continuously synchronize the transfer of data between on-premise and AWS cloud, or for that matter, it could be another cloud and AWS cloud, then AWS Data Sync would be a good fit, where Data Sync scans for differences between source and destination locations and transfer the data that has been changed from the source to the destination. You can also periodically schedule these transfers as well without the need to write any kind of script or code. Now, AWS Application Migration Service, or MGN, mainly is targeting large-scale migration of compute resources and applications. You can use AWS Application Migration Service to migrate your applications to AWS from physical servers, from virtual such as VMware and Microsoft Hyper-V. You can also use it to migrate off the public cloud providers as well to AWS Cloud. You can also AWS Application Migration Service to migrate EC2 instances from AWS from one region to another, or from one AWS account to another as well. Now, DMS, or Database Migration Service, is a managed migration and replication service that helps you move databases and analytics workload to AWS very quickly and in a secure manner with minimal downtime and zero data loss. DMS supports migration between more than 20 database engines and analytics engines, such as you can do it for migration from Oracle to Amazon Aurora MySQL, or maybe MySQL to Amazon RDS, which is Relational Database Service, or from Microsoft SQL Server to Amazon Aurora PostgreSQL. But more on this to come. Now, AWS Snow Family enables you to transfer large amounts of data to and from AWS Cloud Storage, which is also ideal for areas where connectivity is not reliable, or you have some limitations in terms of internet bandwidth, and this basically makes the transfer or online transfer very problematic for you and time-consuming. So starting with the snow cone, which is the smallest of the snow family, and it's a sturdy, rugged product that helps you to collect and process and transfer data to AWS. You can do this either offline by shipping the device actually back to AWS once you put data on it, or online with AWS Data Sync. It's small in terms of dimensions. It's around 8.9 inches long with 5.8 inches wide and 3.25 inches tall. It weighs around 2 kgs and is equipped with some compute and processing power of 2 vCPU and 4 GB of RAM. It can come with 8 or 14 terabytes of storage, which makes it ideal in industrial and manufacturing remote size for data transfer and processing. AWS Snowball is the bigger device that comes with 2 flavors: a Snowball Edge compute optimized device, which is suited for running processing workloads offline on premise. It features 104 vCPU with 24 terabyte of NVMe SSD storage and up to 100 gigabit networking. But if we're targeting mainly large data offline transfer, then the Snowball Edge storage optimized device is a good fit for you, as it provides up to 80, and with the newer devices we have up to 210 terabyte of storage with around 100 gigabit of networking, or up to 100 gigabit of network connectivity. Now, lastly, data center exabyte scale data migration, we have something called Snowmobile, which is basically a secure data truck with up to 100 petabyte of storage capacity that can be dispatched to your site and connected directly to your network backbone to perform high-speed data migration. You can migrate quickly exabyte of data using 10 snowmobiles in parallel from a single or multiple locations. Now, AWS Storage Gateway is another service that allows you to do hybrid cloud storage. It presents itself as either a file, a block storage volume, or even a virtual tape that can be part of your virtual tape library. Now, data transfers through Storage Gateway gets transferred to our S3 storage, which has, again, 11 nines of reliability, with the most frequently used portion of that data will be still cached on-premise for immediate access. So this basically doesn't tax your network while you use your data locally, and have the peace of mind that it is actually still stored in storage. Now, with so many of these services available in AWS, the question that comes to one's mind is, which one should I use? Now, the answer is, it depends. And now, in this case, it depends on the case and the answers that you provide in the initial questions of why am I moving data to the cloud and what kind of data I'm moving. Now, before we get to the use case, there are a few constraints or requirements that will also help determine which service technology to use. Now, constraints such as connectivity, bandwidth, reliability, and the time frame that you need the data to be transferred in will help you determine if you are better off with an offline or an online data transfer service. Now, you should consider one of the online data migration services such as DataSync or DMS or MGN or Storage Gateway or even Transfer Family for faster continuous migration of data. And if you basically have a stable enough internet connectivity, or even if you have configured Direct Connect to establish a reliable private network connection with the AWS cloud using our backbone infrastructure. On the other hand, if your bandwidth is limited and you have a huge amounts of data for initial migration, and maybe you're anticipating periodic data transfer to occur, but not as frequent, and you have flexible timetable for that data transfer to occur, and as we said, you might have some network reliability as well, then Snow Family could be a best fit for you. One thing to note that it shouldn't be either or choice. You can, for instance, utilize Snowball for an initial bulk migration, and then utilize subsequently DataSync or storage gateway for subsequent data transfers online. Another factor that comes into play in determining whether to go offline or online data migration approach is the size of the data being transferred. Now, this table provides you a rough guidance on whether to go for offline data transfer using Snow Family service, for example, or the factor, or using data sync for online data transfer. For instance, if I have 1 gigabit per second connection and my connection is stable enough and it's reliable, it will take me about 58 days to transfer 500 terabytes of data using online data migration services like DataSync or Storage Gateway. Now, this is taking consideration, this is a continuous 24/7 active transfer consuming the whole of the 1 gigabit per second bandwidth. Now, while in some cases this time frame might be acceptable, but for most migration cases, that would be too much of a time needed just to transfer 500 terabytes of data. Hence, this data transfer using multiple Snow devices, for instance, could prove basically more efficient. On the other hand, if we had a bigger bandwidth, say 2 gigabit per second, it would take us about 29 days to transfer that 500 terabytes of data, which is a reasonable time frame for most use cases, as it is a long enough duration for you perhaps to plan for other workloads migration to the cloud while the transfer is going on, which usually comes hand in hand with data migration, but not long enough to basically block or hinder the implementation of the migration of these other workloads. Now, this table, as I said, it gives you a bit of guidance, where green boxes are cases where it's recommended to be using for data sync or online data migration services, and orange boxes represents candidate scenarios for offline or Snow Family. However, you need to assess your own workload and your own workload migration objectives, which depends on the answer we provided earlier of what you're moving and how you're going to use it. Now, another factor that will determine the use of online or offline as well is the restrictions that comes from protocol support of legacy platforms like mainframes or Unix-based systems running big data or database services on legacy file systems, which would require you to do a bit of data transformation for consumption. And such things like FAT32, for example, would require you to do that kind of transformation. Now, let's have a look at the use cases. Now, some production use cases that comes into mind and scenarios is that maybe you want to transfer files from and to your business-to-business partners, and you don't want to deal with the extra undifferentiated management workload of managing your SFTP or FTPS servers, and you don't want to tax your network as well. And we'll be able to, to scale based on demand. If you have higher demand on the transfers, you'll be able to scale up with your servers and scale down if you don't have that demand. Now, this is a good use case for AWS Transfer Family where it can fit this actual requirements. Another use case could be migrating your databases to cloud, maybe entirely, or even creating a replica for HA or for DR considerations, where you want to have both the source and the destination databases in sync at all times. Now, this is where Database Migration Service or AWS DMS would be able to help in that scenario. Now, migrating applications, VMs, and physical hardware to AWS is made very easy with AWS MGN or Application Migration Service, which is also capable of establishing cross-region migration for the multi-region deployment in the cloud, or for maximizing your resiliency of running workloads across 2 or more regions. Now, it provides the capacity of even doing non-intrusive testing of the DR environment as easy as a few clicks. Now, these services work well for structured data. What about non-structured data, such as binary files or maybe Hadoop distributed file system? This is where Data Sync would be a great fit for your online data transfer. It can do transfer between on-premise and AWS cloud storage services such as FSx, S3, FSx for ONTAP, but more on that in details in a minute. You will need to have a reliable network connection though, and basically to have an optimum performance. Another use case is where you need to move data into AWS Cloud, make it available to others that geographically distributed. However, you still have local applications that are dependent on that data, and they need immediate access for it. If this is the case, then you're talking about hybrid storage solutions, and AWS Storage Gateway is your best bet. Now, in your initial journey for the cloud migration, you might need to move large chunks of data in tens or hundreds or even thousands of terabytes, such as when you need to move some machine learning training data or some analytics data, while you might have the bandwidth restrictions for it that you can't, you don't have enough bandwidth for it to make it worth less than months kind of transfer job, and data sync will be ineffective. This is where your Snow family comes into play. You can do it, or you can use Snow basically to do the initial bulk of migration of the data. And once the data is stored in AWS, then you can use, for example, DataSync to keep that data up to date. Now, some of the other popular data migration use cases in the cloud involve using the cloud as a backup strategy for basically having resiliency, or maybe to free up some storage on your on-premise by offloading, for example, old archives, or it could be as part of your modernized business continuity or DR plan. Now, DataSync will be a good fit if you have good internet connection that is reliable and you have high bandwidth, as we said, and if the timeline is usually very flexible, because that's basically the case with DR or having the cloud as a backup. You don't need to have the data at once. Now, while Snow Family is the go-to service where it involves hundreds of terabytes of archival data, especially if you have connection limitations, as we said, or your data exists in an environment that is not so friendly for electronics or for compute resources. Now, if you're using, for example, LTO tapes, or tapes basically as a medium for your archive and storage, basically Snowball can actually have a tape gateway, storage gateway installed on it that you can integrate it, and it will appear to your existing backup and archival solution as a virtual tape library. But more on that to come in a minute. Now, storage gateway is a great fit where you need to back up your data to the cloud and keep a small copy of that on premise, maybe for reporting or for analytics. It will be cached on premise as a service. So part of that data that you define can be cached on premise, where the majority of that data, of the archival data, will be on the cloud. Hence, you will be saving some storage space and cost. Now, in addition to these services, AWS has a vast network of partners that provide backup and restore solutions and disaster recovery solutions as well, that you can access from our AWS marketplace. Now, many of these partners have on-premise solutions as well, which will make your cloud migration journey seamless. Now that we have explored the use cases and possible options for each of these use cases, let's have a deeper look into each one of these services and how they actually work. Now, the AWS Transfer Family is a fully managed supported services for transfer of files of SFTP, AS2, FTPS, and FTP. You basically create your own server or transfer server that supports these protocols, and the data itself will be stored in Amazon S3 or on Amazon EFS. You can migrate, automate, and monitor your file transfer workflows by maintaining existing client-side configuration. So basically, you don't need to change anything on the client side in terms of authentication, access, and firewalls. So all it takes is just 3 simple steps. First, you basically create an always-on server endpoint that enable either SFTP, FTPS, or FTP, and you select the protocol that you need to enable on these servers. Next, you configure the user access using AWS Transfer Family, either built-in authentication manager, or you can integrate it with Microsoft Active Directory, or any third-party identity provider like Okta or Azure AD. Finally, you select a server to either access S3 bucket or an EFS file system. Once protocols, the identity, and the access to file system are enabled, your users can continue to use their existing SFTP or FTPS clients and configurations without any need to change. Now, we discussed before that you can use AWS Data Sync to migrate data located on premises or at the edge or even other cloud providers to Amazon S3, Amazon EFS, FSX for Windows file server, FSX for Lustre, and FSX for OpenZFS. and also FSX for NetApp OneTap. Now, to start with AWS DataSync, you first create and deploy an agent. Now, that agent, you deploy it on-premise or in the cloud provider where you want to migrate the data off. Now, the agent is implemented as a VM image, which is using your hypervisor of choice. It could be VMware or Microsoft Hyper-V, or even EC2 if you're doing region-to-region migration, for instance. Then you create a location. Basically, you create two locations in DataSync. One of them will serve as a source location pointing perhaps to the on-premise agent, and a destination location that would basically be one of our AWS storage services if you're migrating from on-premise to AWS cloud. Now, after setting the locations and the agents, you can create DataSync task. Now, that task will initiate the data transfer from the defined source location to the destination location. Now, the initial sync can be triggered with these tasks manually. You can also schedule subsequent synchronization that will scan the source location for change data and transfer it to the destination location. You can also define rules for filtering what gets transferred and what happens, for example, if the source location has some files or some data deleted or overwritten. Should it be also deleted and overwritten in the destination or not? Now, you can monitor the transfer as well using CloudWatch. And maybe it's worth mentioning as well that if you'd like to transfer operation to happen through private networking connection, like Direct Connect or VPN, AWS also supports that on DataSync. Now, we mentioned that MGN earlier is helpful for application migration. Now, as a service, it would help you migrate workloads and applications on VMs or hardware level even. It is designed for large-scale migration for both data and applications running on these computer sources. You start with MGN by deploying AWS replication agents on the source machines, and basically that you are trying to replicate from, which will in turn automatically discover the block storage volumes that are attached to these machines. Then you create a staging area subnet in AWS VPC in the selected AWS region, and that staging area subnet, it will include a very lightweight Amazon EC2 instance that acts as a replication server. And it will also include a low-cost staging environment to store the EBS volumes. Each source disk that is mapped to a low-cost EBS volume in the staging area subnet will have some storage cost kind of assigned to it. Now, the replication server receives all the data from the agent running on your own source servers, and it tries the data to these staging EBS volumes. Once the replication, one of the replication servers can actually handle multiple sources servers, so you don't really need to worry about the cost of the replication server itself. Now, your replicated data is actually compressed and encrypted in transit, and it actually is also encrypted at rest using EBS encryption. You can control the data replication path using either private connectivity options such as Direct Connect or VPN, or it could be over the public internet. Now, AWS MGN keeps your source servers up to date on AWS using continuous asynchronous block level data replication. So it basically does the replication on block data level. Now, this enables the replication of any application that runs on supported x86 operating systems like Windows or Linux. Now, AWS MGN uses your own defined launch settings to launch new instances when you conduct a non-disruptive DR test, for example, or a cutover test. When you launch a test cutover instance, AWS MGN just automatically converts these source servers to boot and run natively on AWS. The conversion process typically, takes minutes, irrespective of the size of the server, and is executed on all of your servers in parallel as well. So basically, conducting this DR test will have your own DR environment up and running in a matter of minutes. Now, MGN supports migration from to AWS from on-premise environments or from other physical or virtual environments as well, even including private and public clouds. Now, migration from different AWS accounts is also supported, or from other AWS regions is also supported by AWS MGN. You can replicate applications, running on supported operating systems, including legacy applications and complex databases from any infrastructure into AWS. Now, unlike these application-specific migration solutions, AWS MGN supports all workloads, including databases, legacy application, or homegrown applications. It also supports migrating from physical data centers and virtual ones like VMwares and Hyper-Vs and public clouds, as we said. Now, AWS DMS or Database Migration Service is a service that will help you for migrating your SQL databases such as Oracle, SQL Server, MySQL, MariaDB, and PostgreSQL that are sitting on-premise to AWS Cloud. Now, your destination could be a self-managed database instance running on EC2. It could be also AWS RDS, which is our own managed database service. DMS also supports migration of NoSQL databases, such as MongoDB or Cassandra or Redis, for instance, to AWS NoSQL databases such as DocumentDB or ElastiCache. You can do homogeneous migration with DMS, meaning you can move one database engine, or you can move your database from one database engine to a similar engine on the cloud, or you can do also heterogeneous migration with DMS, where you can move your databases from one engine to a totally different engine, like moving from SQL Server to MySQL, for instance. Now, this is possible with the help of a feature called DMS schema conversion, which is basically a fully managed feature that allows you to automatically assess and convert database schemas and code objects at scale with zero downtime. You can set up DMS task for either one-time migration or ongoing replication. An ongoing replication task keeps your source basically and target in sync. Once you set it up, the ongoing replication task will continuously apply source changes to the target with minimal latency. All DMS features such as data validation, transformation are available for replication task. The database migration service is highly resilient and is self-healing. It will continuously monitor the source and the target database. It will monitor the network connectivity and the replication instance. So in case of any interruption, it will automatically restart the process and continues the migration from where it stopped. Now, AWS DMS and SCT or schema conversion tool supports a range of relational databases and non-relational databases as well, in addition to analytics and data warehouses, sources, and targets, which makes this service very crucial when we talk about data migration, as when you're migrating workloads, mostly you will have also databases or let's say some kind of persistence store, either SQL or non-SQL, that are tied to these workloads that will need to migrate. Now, all the data changes that the source database has occurring in the migration, it will be continuously replicated, as we said. It will be continuously synced with the destination databases or destination sources. And as you can see, we have support for over 20 databases, and we keep adding new database engine support as we go on. So just check back very often, as we might have added new services by the time this video is out. Now, as we discussed earlier, Snowball Edge is one of the Snow family services that enables you to do offline migration of your data. You start by requesting one or more Snowball Edge compute devices, or maybe Snowball Edge storage optimized devices in the AWS Management Console, and then you basically specify how much data you need to transfer and the compute needs for local processing if you need to do some local processing on Snowball. You can either opt for 80 terabyte or 210 terabyte storage optimized devices. It depends basically on the availability of these devices in your region. You also select the destination where you want that data to be stored. So it could be an S3 bucket, for instance, and this will be automatically configured, encrypted, and pre-installed on the device before it's shipped to you. Once the device arrives, you connect it to your local network by setting your IP address manually or automatically with DHCP. Then you use something called Snowball Edge client software. And basically that Snowball Edge client software will help you to unlock the Snowball device using job manifest and the unlock code. Now, the manifest and the unlock code, which you can get from the AWS console, are uniquely generated and cryptologically bound to your account. This means that nobody can use them, or nobody can unlock that Snowball unless you give him the proper credentials from your own account. And again, as we said, data copied into Snowball, it will be automatically encrypted and stored in the buckets you specify. Now, all logistics and shipping is done by Amazon, So when copying is complete and the device is ready to be returned, there will be an e-ink shipping label, which is displayed on top of the display screen with Snowball, and this will automatically update to the return address that the Snowball should be delivered to, ensuring that the edge device is delivered to the correct AWS facility. Once the device ships, you can receive tracking notifications on SMS or email through our SNS or Amazon Simple Notification Service, and you can also track it through the console. Once the device arrives at AWS, the data is moved into your selected S3 bucket and the device is sent for secure erasure, making sure that your data is secured at all time. Now, in AWS Storage Gateway, it comes in, as we said, in different flavors. We have the S3 File Gateway, which presents itself as a file interface that the customer can store files as objects in Amazon S3 using NFS or SMB file protocols. Now, your data center will be connected to the file gateway, as I said, through a file gateway VM that you install and deploy in the premise, and you can interact with the file gateway as an SMB and NFS. Once you store that data, or basically you can also use S3 APIs for that matter. Once you store that data, it will go to S3 as a backend for that storage in the cloud, alongside the metadata of the objects like the permissions, the ownership. It will also be stored in S3. Now, Amazon FSx File Gateway, it optimizes on-premise access to Windows file shares on Amazon FSx, making it easy for users to access FSx for Windows file server data with low latency and while conserving your bandwidth. Now, file system operations such as reading and writing files are all performed against the local cache in the FSx file gateway, and then these changes are synchronized in the backend with the actual storage or the actual FSx for Windows file server service. Tape Gateway presents itself as your own existing backup application as an industry standard as SCSI. It presents itself basically as a virtual tape library. It consists of a virtual media changer and virtual tape drives. You can continue to use your existing backup application and workflows while writing to nearly limitless collection of virtual tapes. Each virtual tape is stored in Amazon S3. When you no longer need or require immediate or frequent access to that tape, you can actually port that tape to less costly storage such as Amazon S3 Glacier. Volume Gateway presents itself as a block storage volume using iSCSI protocol. Now, data written to these volumes can be asynchronously backed up as point-in-time snapshots and stored in the cloud as Amazon EBS snapshots. You can back up your on-premise volume gateway volumes using the native snapshot scheduler, or you can use AWS backup service as well. Now, these snapshots are incremental backups that capture changes to the blocks, and it will only transfer the delta of the changes and store them as snapshots. Now, this basically concludes our session today of how to transfer data to AWS and which service is best fit for you. Hopefully you found this session useful, and see you next time for another session of Build on AWS in UAE.